All right, welcome back. In this one, we've just a quick overview of the last video. The last video, we've installed Visual Studio, we've created a new project, we've opened the form, we've added a hello world label to it. Now we are going to add a text box and a button to allow us to change that label. So in this case right here, let's go back to our project. So open your project up again. Let's actually increase the size a little bit so we have some more ground to play with. We're going to center this label because we label 1. Remember, that is label 1. So come over here. Let's grab another label, drop it on here, pull this over. Now in this one, we're actually going to grab a text box as well. Text box. I'm going to drop this down here. I'm going to make it a little bit wider just because I like to add a lot of text to my stuff. And we're going to come up and we're going to add a button. So we're going to drag and drop a button down the middle. Cool part about Visual Studio is you see the blue line pop up there in the corner over here, the blue lines. That tells me whether they're centered and what it is, and it snaps into position for me so that it'll center it for me. So when I'm getting close enough to a button, to a box, it keeps that nice and decent distance space between. Yeah, I mean, you can overlap it like this, but you're not actually going to get too close. So Microsoft has figured out specific spaces between objects that makes it look better, and Visual Studio kind of locks you into that mentality. So, well, actually, what I did was I just highlighted these two together, and I'm just going to move them together as a unit and drop them right here. And we're going to shrink this down a little bit. Take the button, bring it up here. And see the purple line? That purple line means that it's centered all the way across those two. So drop it there, it looks good. Alright, so the button, we're going to change the text on the button. So let's select the button and change the text. The text itself is going to say, instead of button 1, say change label. Alright. And now you see that the text itself, the difference between a label itself, the width is based on the amount of characters on one line, and the height is based on 13, is based on pretty much the height of your text, the pixel height of the text. So if you change the font to be higher, or the font to be bigger, the height of the label will change, though you can't really control yourself. In this case right here, buttons, we control the size of them. So 75 by 23, we can actually control the button itself, and the text, how the text reacts, is all based on the button size. So in this case right here, just grab the bottom corner and bring it down a little bit over, so say 100 by 50, just for giggles. And then we'll just center it again. We'll pull it up, center it. So now we have a label. I'm going to change the label to the text to say enter stuff. And then now you see that it's overlapping with the text box, so we want to be careful with that. So what I'll do is I'm just going to shrink it down. And there. So now we have label 2, which is just a very basic enter stuff label. We don't actually want to control that. So this is where knowing the IDs and knowing the names of our objects inside our world, makes a big difference. So in this case right here, I'm just working on a little bit of just placing and sizing to make it look a little neater. I'm going to show you. This is a little lock technique trick that one of my friends used to use. So the size. So when I click on Form 1 at the top here, it changes the properties to Form 1. So the size is 508 by 158. So one of the developers that I used to work with, what he would like to do was he would change the actual max size and the minimum size to be the same. So that way there you can never actually shrink or grow the frame. It'll always stay the same size. Is it the best way to do it? No, but it definitely, if you've got stuff that you don't, if you're hiding stuff off the screen and you don't want to set the visibility to no, you can use this method to stop them from shrinking and growing the frame. It works. I'm not going to use it because I like to give the users the ability to be able to play around with with my program, and I'll show you a little bit more probably in the next tutorial when we talk about anchors and anchoring stuff within the frame. So in this one right here, so now what we did was we added label 2, we added text box 1, which is an actual typable, and a button. And we're just going to run it so this way here we can see how they interact with the world. So again, this is going to build it with all the new code, and it's going to run it for us. Alright, so from here, you'll see now we have enter stuff, which is not clickable. We now have a text box where we can type text into, and we have a button that we can click on all day, and it does absolutely nothing. And then we have the labels. So labels, duly note, are not selectable, but the text inside we can change that to whatever we want. Now, alright, so now that we got these, we want to make it so that when they click on this button right here, this text gets updates label 1 with this text. So there's 2 different ways to do it. If you know the code already, then you should not be watching this because this is very entry level, and if you know how to create a click event for a button, there's 2 different ways. If you know how to do that, then please do not watch this. You're way beyond us. But the easiest way to do it is just to double click on the button here, and what that'll do is that'll launch the code. So the code itself, when you right click on here, you come down and you'll see, where the heck did it go? Actually, sorry, it's on form 1. My bad, not though. On form 1, if we right click on form 1 and we go view code, this will actually show us the code. Remember, the form design and the code are 2 separate things, because inside of here we're going to see that if we actually break down form 1, we're going to see that there's an initialize components, that there's the dispose initialize components, and then that there's each label. So initialize components itself, this is exactly what we used to do way back in the Java days. This will set up all of your components. So you're going to see label 1, 2, text box, button 1, and that's a button, text box, label. So this is actually defining the physical labels and text boxes itself. Then this is setting up all the variables for those objects within the world. And then down at the very bottom here, we're just adding them. You know, we're adding friends with events. So we're adding with events to the labels. We're just telling the program that each one of these has events. And those events are already predetermined by the .NET compiler what the events are for those. So when we go and code ourselves, we'll handle all those events. So remember, as I said, the code is completely different from the designer. So here's your designer. That's going to be your UI, the visual aspect of your program. And then the code itself does all the background stuff. So first things first, what I always like to do, and this is just good habit. As you become a coder and you work on programs, you develop habits yourself, and those habits are good and bad. The problem is if you develop a bad habit, it's hard to break it, and those bad habits can really hurt your program. For me, good habits that I found is to segregate my code and separate the different functions. So the way that I like to segregate my code is I like to, and I know segregate's kind of a bad word, but I like to separate the code like this. I'll have the main loader up here, which is my base.load, and then down here I'll put object handlers, and then down here I put custom subs, something like that, custom subs, and then custom functions. So we'll go over what a sub and what a function is very, very shortly. Actually, let's do it right now. So a sub itself is kind of like a sub with code. If you know anything about programming, you'll know anything about Visual Basic, or QBasic, or Basic way back in the day. We'll know that Basic, back when we first started writing Basic. Let me do a very quick one here. We'll do one print. This is the actual grammar is not correct. I'm just going to write something very basic. It won't work in a basic compiler, but hopefully you get the hint of what it does. So hello, and then to what the heck was it? To just say read. Yeah, yeah, and then 3 print nice, okay, and then plus yeah. So this was a basic program. We have line 1, line 2, and programs always read from top to bottom. There is some different program styles where it may go in reverse, but for the most part, your program's going to top down. I got to read from the front to back or top to bottom. So what we had to do was, back in the day, we wanted to introduce different functions, but we're going to use them over, well, different subs, but we're going to use them over and over again. So we do something like this: sub, what is your name, return name. But we wanted to ask it so many times, so we'll change this to sub name. So we're going to call this name and then end sub. You'll see this in VBS, Visual Basic Scripting. A lot of times we'll use subs like this just for name. So what we do is we go, so name, so then name again down here. So what it's going to do is going to print hello, and then it's going to run the sub name, and then it's going to go down and say, what is your name, and then it's going to return the name, and then it's going to say read yeah, and then it's going to do that, then it's going to do this again, and then it comes back. So the reason why we use subs is to be able to put one set of code that doesn't return any data back. So actually, sorry, that would be wrong. This piece is wrong because we don't return a name. So we just put what is your name, because the sub does not return any data. So what it would do is it would print hello, print what is your name, then read yeah, then print what is your name, and then print okay plus your name. So plus yeah, whatever yeah is. And the sub, being that the sub doesn't return any data, it's just very basically a sub function that I want to use multiple times over and over again. A lot of cases I will do stuff, for this I'll do stuff like if I have a string that I know I'm going to have to split up, so I get something that comes in, let me just get rid of all this. I get a string that comes in like this, J, yes, awesome. And then I know that I'm going to have to split this up into 3 components. So what I'll do is I'll create a sub, and then the sub will actually split that up for me. And I'll just keep calling the sub with that string, so that way there the sub will just keep splitting it for me, so I don't have to write the same code over and over and over again. Because think about it, if we write the code here, and I write the code here, and I write the code here, when I need to make one change, I got to change it here, here, and here. Whereas if I use a sub, I only have to do it once, and sub, and then I call it here, here, and here. I just change this, and it changes all 3 lines for me. So then I don't have to worry about that. So subs make life a lot easier. Functions are just like subs, except for they return data. So the first instance I wrote you where we return the name, that's a function. So with the function, I'll call them, and I'll ask them for like a Boolean return, true or false, or to return back a string or something like that, and it can return any kind of object. Now, if you're familiar with programming, you know all the different types of objects, integers, objects themselves. You know that we went from just basic strings, integers, and doubles, characters, ASCII codes, all that stuff, to pretty much an objects being anything you want. So with a function, we can return back anything we want. And I'll tell you more about functions later on as we play with them. That's going to be one of the add-ons that we work on. So for this, in this case right here, as I said, what I like to do is have my base.load, which is going to be the code that's ran on loading when we first get here, when we first come into the program. I like to put it all the way up to the very, very, very top. I'll put all my imports here. So we'll do just import system.io, and these are importing custom classes. So if I'm using a class that's not standard within the .NET framework, you import your new class up here, and then that will change everything in here. That'll say, okay, so we're going to use system.io, so I know when I put in file, it's not going to throw me, if I do dim f as file, it's not going to throw up an error, where if I don't have imports here, if I take this out, let me just comment that out. You're gonna see now. See that it turned, now the error comes up, says file is not defined, because the compiler doesn't know what file is. It's looking at the very basic .NET programming, the very, very, very basic .NET Core, and saying file does not exist within your framework. So then we say, all right, well, import system.io, because if we look at it, we see system. We'll do dimff as system.io dot, and we can see all the different types within the IO packet. Within the IO package, you'll see that files here, file access, file attributes, file info. So it knows that within system IO, file is there. So let me just change that to file. So now if I call it like this, and I comment out this, you can use this way of calling it, where you call the namespace, and then you call the sub namespace, and then you call the actual class itself. So calling it like this works. But for simplicity, we just import the whole system IO, and then we're able to call it both ways. We're able to cut out all of these bytes right here by just doing them once. So, in today's world, where storage space is not really much of a problem anymore, back in the day when we first programmed, storage space was really hard, because the 3.5-inch floppy drive took one program today would probably fit on 1,000 of those. So we had to be very, very, very specific on the bytes that we used, and each letter was a byte. So if we could cut out, 20 bytes, it saved us a nice chunk of space. So that's something to remember as we program. I'll talk more about that, because I got some old school programmer mentality where I want to save CPU space, and I want to save hard drive space, I want to save stuff like that, even though in today's world it's not as important as it used to be. To me, there's still some importance left to it. So, all right, so let's get to the fun. So, all I did to get this sub right here was just on the background here, anywhere, just double click, and it'll create it within the code for you. And then for the button, to get the handle on the button, we can either come down here, find the event, and just double click on here, and it'll create it for us. Or we can just double click on the actual button itself. For me, I'm a big fan of double clicking on the actual button. So let's go back here, and we'll double click on the button, and hopefully it should work. I'm not sure exactly why my Visual Studio is being mean to me today. So, but either way, I'll write it right now. Button 1.click. Form VB. Get rid of that. Form. View code. Alright. Now let me just write it quickly. Protected sub. Button 1. Sender as object. E. Sender as object. Comment E as event. Args. Handles. Button 1.click. Bingo. Alright. So essentially we did exactly what it would do. We created a protected sub, button 1, and it handles the button 1.click. So handles and the button function is a key to telling when they call with events from the initializer down here. When we call button 1 is a friend with events, button 1 is button. This is one of the events. Click. All these are the events that will fire off. So when I hit period, all of these events can be fired off. Auto size change, we can make custom code so that when it auto changes, it runs our custom code. When the background color is changed, run some code. We got all that fun stuff to do. But in this case, we're just going to use .click. So, all right. So inside of here, we want to remember what the scope of our project is that when they click on this button, we want to take the text from here and put it on this label. So what we're going to do in Visual Basic, if you know Visual Basic, by this point you should have some kind of grip on Visual Basic. We're gonna go about doing this in two different ways. I'm going to do it the long way first, and then we're going to actually break it down to the most simplest form for you. So the long way is to first define a variable as to what the text is. So I'm going to call dim tb textbox underscore text, and we're going to actually give it a type as string because it's going to be a string, and equal, and we're actually going to declare it as blank. So this is just for training purposes. This is not the way that we would do it in a real environment. And I'll show you the way that we're going to do it in a real environment because it's a lot easier than this. In this case right here, if I'm going to use this call, if I'm going to use the text that's entered multiple times, I will define a variable for it and just call back to the variable instead of making the long call to to go back to the UI and come back. Because to go from the code to the UI and back, it's like kind of a round trip type deal. Think of it as going from your computer to a server and coming back. You're making one trip, and every time you do that, you go back to the UI and you come back. It takes a little bit more computational work. So what we do is we do that once, and then we store within the program that one variable, and we refer to that variable as the text. So by calling the variable inside the program, we're not having to go back to the UI and come back. We're just having to stay within our program and keep using it over and over again. So in this case right here, I've defined TB_text as string with nothing. Now I'm going to actually change that to equal TB_equals, and we're going to call text box 1 because that's the name of this text box. So we come over here, we go to name text box 1, and what do we want? What part of that text box do we want? We go text box 1 period, and then it tells me everything. So I don't want to append text to it because I'd be adding text to the text box. That's crazy. We want to get the current text, so let's go with text. So TB_text equals text box 1.text, and that changed this variable from blank to actually whatever that text is. So now the next thing that we want to do is, now that we have a variable with text in it, we want to change label 1's text to equal that. So down here we don't have to define the label 1 because label 1 is already defined in the compiler. The compiler knows that the name label 1 is that piece. So now we can just call label1.text equals TB_text. Bingo. So now let's run this and see what it does. So when we run it, I'm going to just basically do this. I'm going to do that, hit change, and now you see that the label changed. So if I change this to, say, Jason Rocks, just for fun, hit change label, bam, it changed. So this right here, this code right here says TB1 text is nothing, then the text equals the text that's in text box 1, and then label 1 text equals whatever the text is. So in a roundabout way, we're taking this and putting it here. Now, that's the long way of doing it, and the reason why I do it the long way is because it's going to give you a little bit of a view as to what we do later on and why we're doing it, and the reasons for using local variables as opposed to going the long way, as opposed to going from the code to the front, back to the code, to the front, back to the code, to the front. It's kind of crazy to do that. So using local labels, because it's stored in a different part of the memory, you'll see that our memory in megabytes is low, and our CPU process, because of the little round trips, we're not really going high. So that's where I use this over here. Is I like to take a look at the megabytes in memory that we're using to make sure that we're not using up all the system's memory. Because when we actually go into task panel over here, task manager, sorry, and we look at the memory that's being used, and we look at the hello world used 3.8 megabytes, you can see that over here, even though it says 16, it's not right. It's only 3.8. I think the rest of the megabytes is going to be used by some of these background pieces over here. But this memory usage stays low. So when we're talking about round trips, when we're talking about calling code, going back and forth, the more that we go from the code to the front to back, we're taxing the CPU and we're adding more memory to it. Even though the memory does get released during breakpoints, we still don't want to tie up that much memory. So we don't want to have to do as much computational work if we don't have to. So in this case right here, to simplify this, to make it all very easy, because we're not worried about storing this text, we're just worried about taking the text here and putting it down here, we can actually get rid of almost all of this stuff right here. And we can change this, so we'll just kind of comment it out. So highlight it all, hold down Control, press K, C, and that'll comment out all the code. And we're just going to do this. We're going to go label1.text equals textbox1.text. As simple. Very, very easy. We're not storing it off. We're just simply saying when we click the button, take the text box 1 and make label 1's text that. So let's go F5. And we're going to test this again. So now that we cut 3 lines of code down to 1, which I'm very good at, I'm normally doing Jason's test, and now you see that it's done. So if I add stuff to here, it adds it to that label, and it keeps going. And so that right there is my tutorial on basic text box, throwing a label, text box, hitting that, and updating stuff with the text from a text box. In the next one, I'm going to use, we're actually going to talk about positioning and centering within the application. So we'll talk about adding more stuff and interacting with more labels and more text boxes, and we'll build this program up a little bit better. But for now, I'm going to go drink a coffee. So I will be back with part 3.